Anticipated 50% increase in robotics applications across aerospace, telecommunications, and environmental monitoring by 2027, a competitive analysis of global players like NASA, ESA, and SpaceX. Executive Summary. The robotics industry is expected to witness a significant 50% increase in applications across the aerospace, telecommunications, and environmental monitoring sectors by 2027. This report analyzes the competitive landscape, focusing on key global players such as NASA, the European Space Agency, ESA, and SpaceX, while also highlighting market growth trends and challenges. The insights presented here are based on various market research sources, providing a comprehensive view of emerging trends and future prospects. Market growth and trends. Aerospace robotics market. The aerospace robotics market is projected to grow from $2.9 billion in 2020 to $9.2 billion by 2030, achieving a compound annual growth rate (CAGR) of 12.69% from 2021 to 2030. According to Allied Market Research, the growth is attributed to technological advancements. Innovations in automation and robotics technologies are driving efficiency and precision in aerospace operations. Increased R&D activities. Investment in research and development is essential for creating reliable and efficient aerospace robotics systems. Rising demand for automation. There is a growing need for automated solutions in aerospace operations to enhance productivity and reduce operational costs. Regional insights. North America is currently the dominant market, particularly due to advancements in the U.S. aerospace sector. However, the Asia-Pacific region is expected to see substantial growth due to the rising adoption of robotics in countries like China and India. Applications and segmentation. Key applications in aerospace. Robotics applications in the aerospace sector include drilling, welding, painting, inspection. Among these, drilling is identified as the highest revenue-generating segment. The market is further segmented into traditional and collaborative robotics, with collaborative solutions anticipated to experience significant growth as companies seek more integrated and flexible approaches. Robotics types. The aerospace robotics market comprises various types of robotics, including articulated robots, currently dominate the market due to their versatility and application in numerous aerospace processes. Cylindrical and SCARA robots, expected to grow as more diverse applications emerge. Key players and competitive analysis. Major industry players. The competitive landscape features several key players. AB. Fanuc Corporation. KUKA AG. NASA. European Space Agency ESA. SpaceX. These companies are investing heavily in enhancing their technology portfolios and operational efficiencies to capture more market share. Notably, NASA and ESA not only compete but also collaborate on various initiatives aimed at advancing robotic applications in space exploration and environmental monitoring. Competitive strategies. Innovation. Companies are focusing on developing cutting-edge robotic technologies to improve efficiency and reduce costs. Partnerships. Collaborations between private companies and government agencies are essential for fostering innovation and facilitating large-scale deployments of robotics technologies. Challenges and opportunities. Industry challenges. The aerospace robotics market faces several challenges, including skilled labor shortage. There is a significant shortage of professionals skilled in developing and implementing advanced robotics technologies, which could hinder market growth. High implementation costs. The initial costs associated with robotics technology adoption can be prohibitive for some companies. Emerging opportunities. Despite the challenges, increasing integration of robotics across telecommunications and environmental monitoring sectors presents new opportunities. Cross-sector collaboration, as industries recognize the value of robotics. Opportunities for collaboration across sectors are expanding. Sustainability initiatives. The growing emphasis on environmental sustainability can drive the demand for robotics in monitoring and managing natural resources. Timeline of developments. 2020, the aerospace robotics market was valued at $2.9 billion. 2021 to 2030, anticipated growth at a CAGR of 12.69%. 2025, significant advancements in collaborative robotics expected particularly in the Asia-Pacific region. Conclusion. The anticipated 50% increase in robotics applications by 2027 marks a crucial shift in operational management and innovation across industries. As key players like NASA, ESA, and SpaceX continue to invest in this technology, the competitive landscape will evolve, presenting both challenges and opportunities. Embracing the integration of diverse applications across sectors will be vital for fully harnessing the potential of robotics technology in the coming years. By staying ahead of industry trends and addressing challenges proactively, companies can position themselves favorably in the rapidly evolving robotics market. The anticipated 50% increase in robotics applications across aerospace, telecommunications, and environmental monitoring by 2027 reveals several counterintuitive insights. 1. Labor shortage versus growth. While the aerospace robotics market is projected to grow significantly, the simultaneous shortage of skilled labor presents a paradox. The growth of robotics is typically associated with reducing the need for human labor. However, the complexity and sophistication of new robotics technologies require highly skilled professionals for development and implementation. This suggests that even as robotics take on more tasks, the demand for human expertise in robotics design and maintenance will remain high. 2. Collaborative robotics surge. The expectation that collaborative robotics will outpace traditional robotics growth is surprising. Many might assume that traditional, more established robotic applications would dominate the market due to their reliability and familiarity. However, the shift towards collaborative robots emphasizes flexibility, safety, and integration into human work environments, reflecting a changing paradigm in labor dynamics where humans and robots work side by side rather than in isolation. 3. Regional growth disparities. While North America is currently the leader in the aerospace robotics market, the projected rapid growth in the Asia-Pacific region challenges the notion that technological advancements are solely a Western phenomenon. Countries like China and India are catching up, and their rising investments in robotics indicate that innovation is no longer confined to traditional powerhouses. This counters the stereotype that advanced technological development is exclusive to developed nations. 4. Environmental monitoring as a growth sector. The inclusion of robotics in environmental monitoring may seem less intuitive compared to aerospace and telecommunications, which are typically viewed as more high-tech fields. However, the increasing recognition of robotics' role in monitoring climate change, pollution, and wildlife emphasizes a broadening of robotics applications beyond industrial uses, which could lead to unexpected growth opportunities in sectors traditionally thought to be less technologically driven. 5. Integration of robotics across sectors. The anticipated cross-sector collaboration between aerospace, telecommunications, and environmental monitoring may seem counterintuitive, as these industries are typically viewed as distinct. However, the acknowledgement that robotics can enhance operations across different fields suggests a convergence of technologies and expertise, leading to innovations that may not have been possible within silos. This interdisciplinary approach may unlock new applications in markets challenging traditional industry boundaries. 6. Investment in R&D versus market pressure. The competitive analysis reveals that while major players like NASA, ESA, and SpaceX are investing heavily in R&D, the pressure to reduce costs and improve efficiency may lead to a paradox where breakthroughs are achieved not solely through increased investment but also by leveraging existing technologies more effectively. This suggests a potential shift in strategy. Companies may need to focus on optimizing and integrating technologies rather than continually pushing for groundbreaking innovations, which can be a more sustainable approach in the long run. 7. Impact of policy and regulation. The role of governmental and regulatory bodies may be seen as a hindrance to innovation in robotics, primarily due to the slow pace of policy adaptation to new technologies. However, proactive engagement by organizations like NASA and ESA in establishing guidelines and standards for robotic applications could foster a more robust environment for growth. This counters the common perception that regulation stifles innovation. Instead, it may serve as a framework that enables safer and more effective deployment of robotics technologies. 8. Technological adoption versus cultural resistance. While technological advancements in robotics are rapidly evolving, there may be a cultural resistance to their adoption, particularly in traditional industries. This could lead to an interesting dynamic where, despite the availability of advanced robotic solutions, actual implementation lags due to workforce apprehension or a lack of understanding of new technologies. This highlights the need for educational initiatives and cultural shifts alongside technological advancements to fully realize their potential. These counterintuitive insights suggest that while the future of robotics applications appears promising, the path to achieving anticipated growth will be complex and multifaceted, requiring a nuanced understanding of industry dynamics, workforce implications, and collaborative opportunities. The report on the anticipated 50% increase in robotics applications across aerospace, telecommunications, and environmental monitoring by 2027 presents several key insights, some of which may be easily overlooked yet are significantly impactful for understanding the future landscape of these industries. Here are some of the important content areas that merit closer scrutiny. 1. Collaborative robotics growth. While the report mentions that collaborative robotics is expected to experience significant growth, it is essential to consider why this segment is particularly important. Collaborative robots, or cobots, are designed to work alongside humans, which could lead to a transformation in workplace dynamics. The significance lies in their potential to enhance productivity while ensuring safety and efficiency in tasks that require human oversight. This trend could redefine job roles and necessitate new skill sets, making workforce development a crucial area for companies and educational institutions alike. 2. Regional market dynamics. The report highlights North America's dominance in the aerospace robotics market, driven mainly by the U.S., and suggests that the Asia-Pacific region is expected to grow significantly due to increased adoption in countries like China and India. What often goes unnoticed is the strategic implications of this regional shift. As Asia-Pacific nations ramp up their investment in robotics, they could emerge as formidable competitors in the global market, potentially altering supply chains and manufacturing processes. Companies in North America may need to adapt their strategies to maintain their competitive edge, considering partnerships or investments in these rapidly growing regions. 3. Impact of technological advancements. The report notes that technological advancements are driving growth in the aerospace robotics market. However, it is imperative to recognize that the pace of innovation in robotics could outstrip regulatory frameworks and existing infrastructure, leading to potential implementation challenges. For instance, new technologies such as artificial intelligence, AI, and machine learning could enhance robotic capabilities, but their integration into existing systems may require significant investment and time. The urgency for businesses to stay abreast of technological trends and invest in R&D is a crucial point that may be glossed over. 4. Shortage of skilled labor. A critical challenge identified in the report is the shortage of skilled labor for developing and implementing advanced robotics technology. This issue is substantial because it not only affects the growth potential of the aerospace robotics market but also reflects broader trends in the labor market. The significance of this shortage extends beyond immediate operational impacts. It may lead to increased labor costs, delays in project timelines, and a potential slowdown in innovation. Companies may need to invest in training programs and partnerships with educational institutions to cultivate a skilled workforce. 5. Cross-sector opportunities. The report mentions the increasing integration of robotics in telecommunications and environmental monitoring as areas of opportunity. However, the potential for cross-sector collaboration and innovation often receives insufficient attention. For example, advancements in telecommunications could enhance the data transfer capabilities of environmental monitoring robots, leading to more robust data collection and real-time analysis. Recognizing and harnessing these synergies could unlock new business models and revenue streams, making it crucial for companies to explore interdisciplinary collaborations. 6. Environmental monitoring implications. As robotics applications expand into environmental monitoring, the implications for sustainability practices are profound yet often overlooked. The ability to deploy robots for monitoring ecological changes, assessing pollution levels, and managing natural resources could lead to more informed decision-making and proactive environmental management. Companies that invest in these technologies may not only enhance their operational efficiencies but also position themselves as leaders in sustainability, which is increasingly becoming a competitive differentiator in the market. 7. Competitive collaboration. The presence of organizations like NASA and ESA adds a layer of complexity to the competitive landscape. While these entities are often viewed as competitors, they are also collaborators in various initiatives. The report suggests that understanding how these relationships evolve will be crucial for companies aiming to innovate in aerospace robotics. The potential for joint ventures, shared research, and public-private partnerships could significantly enhance technological advancements and market access for private companies. This collaborative aspect is vital for stakeholders to consider as they strategize their market positioning. 8. Market segmentation insights. The report breaks down the aerospace robotics market into various applications such as drilling, welding, painting, and inspection. However, the implications of this segmentation deserve further exploration. For instance, the emphasis on drilling as the highest revenue-generating segment may lead companies to prioritize investments in that area, potentially overshadowing emerging applications like painting and inspection that could have substantial growth potential. Understanding the full spectrum of market segments and their dynamics will be essential for informed strategic planning. 9. Future of work implications. The anticipated growth in robotics applications will likely have a significant impact on the workforce. The integration of robotics into traditional industries could lead to job displacement as routine tasks become automated. However, it could also create new roles focused on robot maintenance, programming, and oversight. The shift in labor dynamics necessitates a proactive approach to workforce development with an emphasis on reskilling and upskilling existing employees to prepare them for the changing job landscape. The societal implications of this transformation, including economic disparities and access to education, are critical discussions that often remain on the periphery. Conclusion. The report on the anticipated increase in robotics applications across several industries highlights several critical insights that may be overlooked. From the implications of collaborative robotics and regional market dynamics to the challenges posed by skilled labor shortages and the potential for cross-sector opportunities, each element plays a significant role in shaping the future landscape of aerospace telecommunications and environmental monitoring. Companies and stakeholders must consider these factors holistically to navigate the complexities of an evolving market and leverage the full potential of robotics technology. 1. Market growth projections. The aerospace robotics market is expected to experience significant growth, expanding from $2.9 billion in 2020 to $9.2 billion by 2030, with a compound annual growth rate CAGR of 12.69% from 2021 to 2030. This growth is driven by advancements in technology, increased investments in research and development, and a growing demand for automation across various aerospace operations. The North American market, led by the U.S., is currently the largest, but the Asia-Pacific region is projected to see rapid growth, particularly in countries like China and India. 2. Diverse applications and segmentation. The applications of robotics in aerospace are diverse, including critical functions such as drilling, welding, painting, and inspection. Among these, drilling is noted as the highest revenue-generating segment. The market is categorized into traditional and collaborative robotics, with the latter expected to see significant growth as companies look for more integrated and flexible solutions. This segmentation illustrates the evolving needs of the aerospace industry and highlights the importance of adapting to technological advancements. 3. Competitive landscape and key players. The competitive environment is characterized by major players like ABB Fanuc Corporation and KUKA AG, all of which are innovating to enhance their technology portfolios. The presence of organizations such as NASA and the European Space Agency ESA adds complexity to the landscape, as they can act as both competitors and collaborators in advancing robotics applications in aerospace and environmental monitoring. The competition is not just about market share but also about technological supremacy and strategic partnerships. 4. Challenges and opportunities. While the outlook for the aerospace robotics market is generally positive, challenges persist, particularly regarding the shortage of skilled labor necessary for developing and implementing advanced robotics technologies. This skill gap could impede growth if not adequately addressed. Nonetheless, the integration of robotics into telecommunications and environmental monitoring presents new opportunities for innovation and cross-sector collaboration. As industries recognize the potential of robotics to optimize operations, the landscape will likely continue to evolve, highlighting the need for adaptive strategies among key players. 1. The space race 1957 to 1975. This historical period was characterized by intense competition between the United States and the Soviet Union for supremacy in space exploration. The launch of Sputnik by the Soviet Union in 1957 marked the beginning of the space race, leading to significant advancements in aerospace technology and robotics. The U.S. responded with the Apollo program, culminating in the Apollo 11 moon landing in 1969, which showcased the capabilities of robotics in space missions. The competition spurred innovations in various technologies, leading to advancements in telecommunications and environmental monitoring as well. 2. The Industrial Revolution. Late 18th to early 19th century, the Industrial Revolution marked a significant turning point in history, with advancements in machinery and technology transforming industries including textiles manufacturing and transportation. The introduction of mechanized production and steam-powered machinery represented early forms of robotics that increased efficiency and productivity. This revolution not only led to economic growth but also created new sectors and opportunities similar to the anticipated growth in robotics applications across aerospace and other industries today. 3. The Digital Revolution. Late 20th century. This era saw the rise of digital technology fundamentally changing how information is processed and communicated. The introduction of computers and automation transformed industries, leading to significant advancements in telecommunications and data management. Companies like IBM and Microsoft emerged as key players, driving innovation much like NASA, ESA, and SpaceX are doing today in the field of robotics. The digital revolution also laid the groundwork for future advancements in AI and robotics, paralleling the current anticipated increase in robotics applications across various sectors. The future of robotics applications across aerospace, telecommunications, and environmental monitoring is expected to undergo significant transformation by 2027, with a projected increase of 50%. This growth is largely driven by advancements in technology, increasing demand for automation, and the competitive strategies of major global players such as NASA, the European Space Agency ESA, and SpaceX. Below are insights and predictions regarding this anticipated growth and its implications for various sectors. 1. Market dynamics and growth projections. The aerospace robotics market is on a robust growth trajectory, projected to grow from $2.9 billion in 2020 to approximately $9.2 billion by 2030, reflecting a compound annual growth rate (CAGR) of 12.69%. This growth is fueled by technological innovations and the rising demand for automation in aerospace operations. North America currently leads the market, primarily driven by the US, while the Asia-Pacific region is expected to experience rapid growth as countries like China and India increase their adoption of robotics technologies. 2. Key applications and innovations. In the aerospace sector, robotics applications are diversifying with significant uses in drilling, welding, painting, and inspection. Drilling is expected to be the highest revenue-generating segment due to its critical role in aircraft manufacturing. Collaborative robotics, which enhances flexibility and efficiency in operations, will see considerable growth as industries look for integrated solutions. Furthermore, advancements in artificial intelligence and machine learning will facilitate more intelligent and autonomous robotic systems that can perform complex tasks with minimal human intervention. 3. Competitive landscape. The competition among major players like ABB Fanuc Corporation, KUKA AG, NASA, ESA, and SpaceX will shape the future of the robotics market. These organizations are not only competitors but also collaborators, particularly in initiatives related to space exploration and environmental monitoring. Their investments in R&D and technological advancements will lead to improved operational efficiencies and cost reduction, strengthening their market positions. Additionally, as the aerospace industry seeks to optimize costs and enhance safety, partnerships between private companies and governmental space agencies will become increasingly common. 4. Challenges and opportunities. Despite the optimistic outlook, the aerospace robotics market faces challenges, including a shortage of skilled labor. This gap could hinder the development and deployment of advanced robotics technologies. However, this challenge also presents opportunities for educational institutions and training organizations to develop programs that equip the workforce with necessary skills. Additionally, the integration of robotics in telecommunications, such as network management and infrastructure maintenance, and environmental monitoring, such as data collection and analysis, will open new avenues for growth and innovation. 5. Future trends and developments. Looking ahead, several trends are expected to shape the robotics landscape. Increased collaboration. As the lines between aerospace, telecommunications, and environmental monitoring blur, collaborative efforts among companies and agencies will intensify, leading to shared technological advancements and resource optimization. Rise of autonomous systems. The trend towards autonomy will accelerate, with robots capable of performing complex tasks without human oversight. This shift will be particularly beneficial in hazardous environments such as space exploration or disaster response scenarios. Enhanced predictive analytics. The integration of data analytics in robotics will improve predictive maintenance and operational efficiencies, allowing industries to anticipate failures and optimize performance proactively. Sustainability and environmental monitoring. As global focus shifts towards sustainability, robotics will play a pivotal role in environmental monitoring, enabling efficient data collection and analysis for climate research, pollution tracking, and natural resource management. Conclusion. The anticipated 50% increase in robotics applications by 2027 signifies a transformative period for the aerospace, telecommunications, and environmental monitoring sectors. With key players like NASA, ESA, and SpaceX at the forefront, the competitive landscape will continue to evolve, creating new opportunities for growth and innovation. As industries embrace the potential of robotics, the integration of diverse applications across different sectors will be crucial for maximizing the impact of these technologies and addressing upcoming challenges. The next few years promise to be an exciting era for robotics, with profound implications for how industries operate and innovate.